In this recording, we're going to look at a quadratic model for a ball that's thrown up in the air from the top of a 30-foot tall building. So it's modeled by this function here, and I want you to look at a little bit of the structure of that function. First of all, what kind of a parabola is it, given that it has a negative in front? Okay, kind of like this, right? We know it has to be that kind because gravity is going to push it back down eventually. Also want you to be conscious of this plus 30 on the end here. So it says it's a 30-foot tall building, so that's when we're starting the stopwatch on this ball. So basically, when we sub in 0 for the time, that takes care of this term right here, right? That eliminates that term, multiplying by 0. Again, 0 times 80 adds to 0. We got 0 plus 0, 30. So that's our initial height, our y-intercept, our initial height. That's when t equals 0. All right, so that's all important part of the structure here to recognize. So it says make a graphing calculator graph, and then we're going to put the graph onto our paper, labeling the axes with their scales. So we'll pop over here to our graphing calculator, and if you're like me, you've got already something in the y-equals. Let's clear it out. Let's do another thing. Let's go up onto plot 1 and hit enter. So you do not want plot 1 or any of the plots to be highlighted when you are graphing a function that doesn't have to do anything with stat plots. It doesn't matter that there's data in our list. If there is, this will not be graphed because the plot is not on. So go ahead and put that function in there. Okay. At this point, we're not going to hit graph. We're not going to hit zoom, fit, or just randomly press stuff. Let's be more intelligent and efficient about this. So hit second table. I want you to examine the behavior of the y values. Okay, so as x increases, y is increasing up until a certain point, right? Somewhere between 2 and 3, your y values stop increasing. They head down. I mean, we can see somewhere between 5 and 6, the ball hits the ground, right? It reaches a height of 0. So in terms of establishing my window, I can go between like 0 and 6 in the x, and what would you say, maybe 140, 150 for the y's? That should do it, 150. So I'll go to press the window key, and I want 0 to 6 for the x, 0 to 150 for the y. Now you can just hit graph, and that gives me a pretty nice window fit for my function. So I will take a little picture of that and pop that into my notes so that I can graph it. Okay. So I'm going to make a sketch of that, and you are as well. Okay, so make sure you have labels in terms of the unit and the variable and the scale of the axes. It's all good, right? That's our t-axis, that's our h of t, and that's our t-axis. All good? All right. Next, so I don't really need that anymore. Next, we're going to do some stuff with it. Find the maximum height of the ball. When does this maximum occur? Label that point on our graph. So we're going to go to our graphing calculator, pop over here. We're going to go to second calc. You see choice 4 for maximum. Okay. You're going to set up your left bound. So move to the left somewhat. Hit enter. Move to the right, somewhat to the right of that where you can identify the maximum is. Your guess is anywhere in the middle, so it's saying guess at the bottom here. Hit enter. And now I can see the maximum. You know what? That looks like positive 2.5 and a y value of 130. So back up to this point. It says, when does this maximum occur? We can just graph that right out on our graph. So at 2.5 seconds, and so I'm just going to plot that point there. That's 2.5 comma 130. Since I have the y value, I'm just going to put it on there. What is the height at 0.5 seconds after it's thrown? Well, remember doing that little trick? we did second table set. We change our independent variable to be ask, and then we hit second table. And now we can put in, what was it, 0.5 seconds. And it will tell me the y. So 66 seconds, or 66 feet. All right. So go ahead and change your table set to be auto. You don't have to do it this way, but that's a good way to do it. Height after 0.5 seconds, you could substitute it in, or you could use your calculator. But let's show what we did. So that would be something like h of 0.5. Doesn't matter how I use the calculator. I do want to show what it is that my calculator did for me. And this was the calculation. All right, so it says use your graphing calculator to find when the ball will hit the ground. Well, think about what the height is when the ball hits the ground, right? If I look up here, ball hits the ground right about there. So its height when the ball hits the ground is 0. Okay, so there's a couple ways to go about this thing. One is we can go to our graphing calculator and we can graph a second, we can go to second calc and find the 0, the point where the y value equals 0. So go down to choice 2, okay, and it says left bound. So anywhere here, it says 1, 2, 3, 4. Left bound, somewhere to the left, it would be like 5. So I'm just going to press 5 and hit enter. Now it establishes, okay, from there over. Well, the right bound would be somewhere like 6. I know it's between 5 and 6. So the right bound, I'm just going to hit 6. Enter. All right, so you can see it's between 5 and 6. My guess, well, my guess would be anywhere like 5.5. So I'm going to say like 5.5. And it says, in fact, the 0 point is 5.35. And I don't know if it tells me what to round to. It does. So let's round this correctly. 5.4. And then it says to graph, put that on our graph. So that's this point right there, which is 5.4, 0. Finally, last piece says, the ball can be seen from the ground whenever it's at least 100 feet. Use your graph to estimate the interval of time when it can be seen. So I want you to pause the recording until you've made your estimate between what and what time values do you think the ball is at 100 feet. You can use your graphing calculator or your sketch. So, all right, so that's 150 up there. We said it's 130. So I'm going to estimate like 100 is like right in here. Okay, so the interval of time, I'm guessing, is like between maybe 1 and 4 seconds, something like that. So for like, that's my guess. My estimate's between 1 and 4 seconds. And 4. And I'm actually use the calculator to find that out. So we'll come over here. Let's grab a line, the line y equals 100. And we're going to graph a horizontal line on the same axes. And now we just need to find the intersection point here and the intersection point here, and we'll have it. So we'll do second calc intersect, which is number 5. First curve, well, that is the first curve presented at the top, so hit enter. Second curve, yep, that's the second curve, so hit enter. And now your guess. Well, my guess is over here somewhere, like around 1, right? So I'm just going to hit 1. And it was close. It was 1.13 seconds. I'll write that down on my paper. It says round to the 10th, so I'll do that. All right, so that's from the calculator. And then repeat that process. So second calc intersect, which is choice 5. First curve, enter. Second curve, enter. But don't hit guess on here. Your guess, you want to slide over, and you could can move it to the right by using your cursor. I'm using my right arrow, right? I'm just moving that right arrow to get it somewhat close to my guess, which I thought was around 4-ish, and hit enter. And it turns out it's like 3.9. So my guesses were in the ballpark there. Thanks for watching.